Let me welcome you back to another series of this class, which is going to be brief. I'll be talking on inductive couple, plasma, and mass spectrometry. This is another highly sensitive technique you need to grip in this very course of this lecture. What is ICP-MS? It's a powerful technique used to determine trace element and isotopy in a wide range of sample type. I said that earlier that AAS have limitation compared to ICP-MS. Talking about simultaneous determinations of trace of elements in a given sample. A trace of elements in a given sample, a wide range of elements. While AAS is trying to determine one trace element, one elemental, but in ICP-MS, you can detect a wide range of this very element at a given time. Therefore, what is ICP-MS? I say it's a powerful technique used for simultaneous determination of trace element and its isotope in a wide range of samples. It offers high sensitivity, multi-element capability, low detection limit, making it an indispensable tool in field of laboratory medicine. May I let you know that this IMS is hardly to come by, even in the context of Nigeria. Most of the laboratory do not have IMS, except over there in Western world. IMS, it combines the principle of inductive couple plasma and mass spectrometry. And this sample, when a sample is introduced into an argon plasma torch, where it is atomized, ionized, and excited to form a high temperature plasma consisting of ions. These ions are ions, electrons, neutral atoms. The ions are therefore attracted, separated, extracted from the plasma, and then introduced into a mass spectrometer, which measures this very ion based on mass to charge ratio. Please, I want you to understand what I'm trying to explain. Your ions, your elements is injected into this instrument called ICP-MS that work with two principles of inductive couple plasma and mass spectrometric principle. What happened here is that this element that is injected into the argon plasma torch, this argon plasma torch will help to atomize. We have been using that very word, atomize. It will help to free these very elements and make it into a free state atom, ions, in a plasma. And this very plasma will thereby be extracted. The ion in the plasma will be extracted into a mass spectrometer. When the argon plasma torch have atomized the ion in this very plasma, it is at a high level, high energy state. And what happened here is that the ion in that plasma is now extracted into another instrument called mass spectrometry, which now help to determine the mass and the charge ratio of that very particular ion. You see, it's a very good instruments. What are the instrumentation? What are the components? Number one component is that it has a place of sample where a sample is introduced, just like what we have in the flame photometer. We call it nebulizer, that helps to prepare the sample and convert it into an aerosol. And there is a flame, a light, an energy state called the argon plasma torch, or you can use the word ICP torch, which is used to atomize, which is used to break down this very atom into a free state in form of nebulization. Thereafter, the atom that has been atomized in a free state in a gaseous form is now extracted by the mass spectrometer, where this ion is now analyzed based on the mass to charge ratio of that very element. Yes, of that very element. This is just a general procedure on how ICP-MS is all about. It has a lot of advantages. Number one, high sensitivity. Number two, it can determine a lot of elements at a given point in time. That is wide dynamic range. And number three, it can analyze elements based on their isotope. It can analyze elements based on isotope. It has multi-element capability, and also it can quantify elements over a very wide concentration range. But I said there are limitations earlier. Yes, of a truth, Maastricht effect is one of the common limitation encountered by this instrumentation, whereby there is interference from other elements. But if it were to be fluorimetry, we say Quincke phenomenon. Now, not only that, the instrument is cost and complex. Yes, cost and complex. Cost and complex. What are the applications using ICP-MS? Number one, clinical diagnosis. We can use it to measure blood samples, urine samples for presence of trace elements, presence of heavy metals, and also to diagnose diseased conditions. Food industry also make use of it to check purity of their fruits. Drug company also make use of it to quantify some level of impurity present in their drugs. And not only that, environment also use it to monitor environment for impurity in air, in water, in soil, in sediment, and even in hair sample. Can you see a very good reporting? In conclusion, ICP-MS is versatile, widely used analytical techniques in determining trace element and its isotope in a wide range of samples. It has high sensitivity, it has multi-element capability, and it can analyze isotopic nature of sample. Please, I'll be ending this very class, this very series here. I want you to look at other basic instruments that can also be used. Number one is fluorescent spectroscopy, X-ray fluorescent spectroscopy. Please, you will read that up. Also, we have another instrument of importance, which is electron microscopy. Electron microscopy, they are all of importance in our class of instrumentations. They all serve purpose in laboratory medicine. And also, you also try to read electron probe microanalysis. Electron probe microanalysis. With all these points, we'll be able to bring this very class to an end. Please go through the lecture notes that has been sent to you. Study from page to page and create questions that you need to ask. In the course of this lecture, things that are not clear, please you let me know about it. I will be well available to help you to understand this very lecture. Thank you for listening.